presenters today. Each presenter has 25 minutes with 5 minutes of questions. I will send a private chat at 3 minutes, and then play a little twinkle at 1 minute if it's needed. And I think that's probably about it. At the end of every presentation, please give some feedback. I've posted the feedback link in the chat window. I'll repost it after every talk. And then I think on that note, I will let you get started, Mark.
All right, great. Thank you, Justine. All right, good morning, everyone. My name is Mark Prettyman, and today I'll be discussing my proposal on ground level ozone forecasts in the Mid-Atlantic using the analog ensemble. The proposal was developed under the guidance of my advisor, Dr. Guido Cervone. So for my discussion, I'll start by giving you a little bit of background on ozone and forecasts related to air quality and the problem I've identified related to the forecasting of ground level ozone. I'll also offer a potential solution I've identified. I'll then go over the methodology, the results, timeline, and a conference venue for which I expect to present. So I'll start by telling you a little bit about myself and my experience. I'm an environmental scientist with the Delaware Division of Air Quality. I've worked there for nearly 18 years. I've had many hats. My current hat is the lead scientist related to all planning efforts related to ground level ozone. This has included the estimation of emissions from sources which contribute to ground level ozone, the analysis of such emissions, such as power plant emissions, and the development of regulations to control emissions that contribute to ozone. So I actually have a pop quiz for everyone. Who likes to breathe clean air? All right, I think I see everyone raising their hand through the internet. And that's a good thing. I think we all like to breathe clean air. I mean, who doesn't? Depending on where you live, though, the air you breathe may not be as clean as you think, especially if you live on the East Coast near the Mid-Atlantic. One of the most important contributors to bad air quality is ground level ozone. It's a pollutant that's very harmful to human health in very high concentrations. People who are especially susceptible to it are the young, the elderly, and those with respiratory issues such as asthma. Ozone isn't directly emitted to the atmosphere, but instead it's formed from the reaction of precursor pollutants in the presence of sunlight. And to be clear, I'm not talking about stratospheric ozone. That's the stuff way up high that helps to protect us from the sun's radiation. I'm talking about ground level ozone, and the best way to remember what's good and bad is the phrase, good up high, bad nearby. Help protect U.S. citizens from bad air quality, the EPA has set up various standards known as the NAAQS for different pollutants, one of which is ozone. The current ozone NAAQS was finalized in 2015, and it's set at a level of 0.070 parts per million, more readily rememberable as 70 parts per billion. The form of the standard is a little bit complicated, but I'll explain it. It's a 3-year average of the 4th highest daily maximum 8-hour ozone concentration. Now, working backwards, it's a little easier to understand. So there's monitors around the country that record ambient air quality, ozone and many other pollutants. So we have an hourly ozone concentration. Every hour of the day, you average the 8 hours from that hour going forward. So you have 24-hour, 8-hour averages every day. You rank them, and then you take the highest of those 8-hour averages, and then you rank them per year to get the 4th highest daily average. With the 4th highest daily averages, you then average them over 3 years, and that 3-year average is then compared to the standard of 70 ppb. And in context, the last standard was 75 ppb that was set in 2008. So we are coming down, but there's still a lot of areas that aren't meeting the standard. Delaware is one of those areas which is not meeting the standard, or rather not attaining the standard. And Delaware is actually part of a multi-state non-attainment area. And I'll show that here in this image. So this is a map of Delaware and the states surrounding it. I'll first point you to the dots on the map. The dots represent those ozone monitors that I was talking about. I've color-coded them based upon that 3-year average, also known as a design value. You can see many of them are green, which are below the standard of 70 parts per billion. But those that I've circled with red, those are the ones that are high. And you can see that they kind of go along this area, which is basically urban population centers going from DC, Baltimore, Wilmington, Philadelphia, and all up to Trenton. It also follows the I-95 corridor. So people and mobile sources are a big factor in the creation of ozone. And it's a little premature, but I'll also point you to this red bounding box that I have here. This is going to be my project domain, which doesn't mean much, but it'll make sense shortly. The project domain is simply the area I'm trying to capture with my project, because it's capturing this area where there's a lot of monitors that aren't attaining the standard, basically those with high ozone. So pop quiz question number 2. Wouldn't you like to know when air quality is bad? Of course you would. Who wouldn't want to know? I mean, especially if you're part of that sensitive population of either the young, the elderly, or those with respiratory problems. In Delaware alone, we don't have just less than 1 million people, but we have 16% of the population that have a lung disease such as asthma. This figure comes from the American Lung Association. And along that I-95 corridor I was showing you in the previous picture, going from DC up to Trenton, those major urban population centers, similarly, they have between 13 and 16% of the population with a lung disease such as asthma. So what do we do about this? Again, we want to know when air quality is bad, but how do we know? So the EPA has created an air quality index to help notify the public when there's bad air quality. It's basically a range that's color-coded for simplification. And the best thing to remember is that a code orange or worse is a violation of the standard. That's when the air quality is expected to be above that 70 ppb. It's set at so that 100 or 101 actually is a code orange and higher. And the EPA forecasts these values. State agencies such as my own, we forecast these values. And we notify the public so that they're aware when there's going to be this bad air quality. We ask them to, hey, limit your exposure outside, take a bike or walk as opposed to driving your car. Don't mow until the evening so that you can reduce emissions that contribute to ozone. We even have regulatory requirements, or rather restrictions, related to when there is a code orange forecast or not. So here's a quick example of Delaware's own air quality forecast website. And I've chosen the date of June 27th, 2019 specifically because June 27th is a code orange day. The forecasters, which Delaware has previously, up until recently, contracted with Penn State University's Department of Meteorology to prepare the air quality forecast. So on the 27th, they forecast an AQI value of 101. So just above the standard. It's going to be bad. So we issue this to help let the people know, to limit their exposure. Following day is even going to be bad. It was forecast to be 105. We want to get this information out there. So this happens every single day. And in fact, we try to issue this forecast by 4 p.m. the day prior to give people time to know and plan their day ahead, which means that the Penn State forecasters kind of have to rush. They have to report to EPA before 3 p.m., meaning that they have to put together everything that they need to but well before 3 p.m. in order to issue these forecasts. And there kind of lies the problem. To create these forecasts, it takes a lot of resources. Delaware contracts with Penn State, other state agencies have staff meteorologists to prepare these forecasts. And the forecasts are great, but there's these problems, as I mentioned, created to it. And a lot of it comes down to time. The time comes from the development of the forecast and models related to preparing what you think the air quality is going to be. And a lot of air quality depends on meteorology. Meteorology depends on models. Many models are deterministic in that they create one future determination in the future. Many models are computationally expensive. You even need a large computer, maybe a supercomputer even to create that. You have a lot of inputs that go into it, and you get one determination. If things are off, you may have to run it again. You may have to change something and you run it again. It takes a lot of time and resources, things that you just can't really rely on when creating an air quality forecast every day that has to be done by 3 p.m. A couple quick examples that I'll point out are EPA has the CAMX model. It forecasts ozone either a couple days ahead or years in the future, but it takes months and months to try to estimate air quality using this. It takes a lot to go into it. Similarly, the NOAA has the WRF model, which forecasts it forecasts weather, and it does it actually kind of all the time, all over the North America, and it forecasts different parameters: temperature, wind speed, wind direction, precipitation. It's a lot of data, and it takes a lot to do this. Now, getting back to the AQI forecast, you have these deterministic models. You have to take into account meteorology, which Penn State Meteorology Department, who better to do that? But you also have to be aware of these emission trends, because it takes emissions, the precursor pollutants, to create this ozone. And there's a lot of things that can go wrong. It's scientific, but it's not very accurate. I don't want to say it's almost an educated guess, but it kind of is. Here's a quick metric prepared by Penn State that they give to the state of Delaware to show how well they're forecasting air quality for us. The purple bars are the hits when they correctly forecast, and the pink bars are the false alarms. As you can see, they're kind of up and down with the hits and up and down with the false alarms. Another way to look at this is actually the false alarm ratio and a hit rate. So the hit rate, you want to be 1. False alarm ratio, you want to be 0. The red false alarm ratio basically, again, is when they're forecasting an exceedance that doesn't pan out. And the blue bar, the hit rate, of course, you want to be 1. You want to say, hey, I forecasted 5 days to be an exceedance, and it actually happened. But again, you can see from the charts, the forecasting ability by Penn State is good, but is it great? What if there was a different way to do this? What if there was an easier, faster, and cheaper way to prepare these forecasts? Enter Dr. Luca Dell'Amoniche. Dr. Luca Dell'Amoniche is currently, he's the Deputy Director for Center of Western Weather and Water Extremes in San Diego. He has a very impressive CV, but I want to point out that, his career has centered around his work and interests related to ensemble methods, probabilistic prediction, uncertainty quantification, and most specifically, numerical weather prediction. Dr. Dell'Amoniche, he helped to develop the first ensemble for air quality prediction. And this has led to the creation of what he now calls the analog ensemble technique. The analog ensemble technique, or more simply, ANN, it basically uses a deterministic forecast, but it looks to the past to predict the future. And it looks to the past to correlate past observations to predict the future. What you end up with is a probabilistic forecast. A lot of the papers written by Dr. Dell'Amoniche and many other folks have used the ANN to predict many meteorological related parameters, as you can see on the screen, but most importantly, it's been used recently as a paper in 2018 to predict air quality, including ozone. This graphic was prepared by Dr. Dell'Amoniche, and I think it's a better representation of what the ANN really does. I'll first point you to this black box here. It's a future deterministic forecast from a single deterministic model. Now, if you look back through time, what's known as kind of the training period, you can find deterministic forecasts in the past that match the future deterministic forecast. These past ones match based on different parameters, whether it be the temperature, wind, precipitation, solar radiation. The past forecasts in the blue boxes are then used to select actual observed values that match at that specific day and time, which are represented as the green boxes. These past observations, green, are essentially known as an analog, and they're used to help develop the probabilistic forecast. So you can say that the ANN provides a multivariate forecast in time and space. The ANN's forecast is a probability distribution of the real value. It's all based on one deterministic model and actual observations, as opposed to using multiple deterministic models to estimate some sort of probable forecast. So we've talked about how existing forecasts are performed for air quality, and we've talked about this new technique for forecasting, which has various advantages over your typical forecasting. The expertise-driven forecasts, such as those prepared for Delaware by Penn State, they're good, but are they really great? Then we have this new technology, the data-driven. It's shown to work. It's supposedly quicker. It's less computing or computing power. It's less computationally sensitive because you're working with one model instead of running multiple models. So as part of my project, I've come up with a goal or a question for the goal of what can drive a better ozone forecast, expertise or data? Data can actually provide the better forecast. Delamonicky's work has shown that it works for ozone. And what I'm going to do is I'm going to test the ANN to see how well it performs at the monitors in and around Delaware. If you remember back to the map I showed previously, there's actually 51 monitors in that project domain that I identified. I'm going to compare the forecast of ANN for those 51 compared to what the actual observations are and the forecast developed for them from Penn State or the state organizations that have developed those forecasts. This is a rough flow chart of what my project is and how it's going to proceed. So there is the ANN model. It's been prepared as an R package that can be run on a computer. Using the R package of ANN, we can use it to prepare or to forecast hourly ozone in the next 24 to 48 hours. Using those hourly forecasts, similar to what I was referring to back when I was talking about the standard form of the ozone standard, it's an 8-hour standard. So we take the hourly ozone, we calculate the 8-hour ozone. We rank them per day and we figure out what the max ozone is per day. We take the max and we calculate it, we convert it into an AQI value. And with that ANN predicted or forecasted AQI value, we compare it to the historic AQI forecast. As I've discussed, the ANN really needs two sets of data to work, a deterministic forecast and actual observations. I'm going to be using 2015, 2016, 2017, and 2018 data. The deterministic forecast is going to be meteorological data provided by Noah's Wharf model. The observed data is going to be actual hourly observations recorded from every state that's uploaded to EPA. I have access to both. That'll work very well. 3 years of data are going to be used in such that the 15, 16, 17 Met data, that's going to be used as a training period. Those were the blue boxes, if you remember me talking about in the previous slide that had the description of the ANN technique. 2017 ozone data, that's going to be the analog. Those were the green boxes that we're trying to figure out as an analog, basically a representation of what the real values are. And then we're going to use the actual 2018 ozone data for data verification. So the technology that I need for this project is actually really simple, a laptop. I have the R package installed on my computer. So I have the ANN, I have RStudio. We have the WRF data. I won't say kind of in-house, but at least Penn State has access to it, which I can obtain. I have direct access to the observed ozone data as it's freely available through EPA. I don't need a supercomputer. I have a gaming laptop. It's a good processor, has a reasonable amount of RAM, but that's the benefit of the ANN. You don't need a supercomputer. You can run this on a regular laptop, a regular computer, and get results. So the project seems straightforward, and it is really, but there's various factors that have to be considered along with the project. One of which is the number of analogs that are searched for in that past training period. Since you have a multiple set of analogs that's being used to create a probabilistic forecast, if you have too few or too many, it may throw off the uncertainty. You may have a large uncertainty. Of course, you want to have the smallest uncertainty possible. So there's going to be a little bit of tailoring to ensure that we find the correct number of analogs. Dr. Delamonake's 2018 paper started with 20 analogs. So that's where I'm going to start with. And I think that the 2015, 16, 17 data would be a good repository to start with to get those 20 analogs. And the length of the search period goes right along with it. If it's too short, you use 1 year, you're not going to get enough analogs for that probabilistic determination. Another factor there's a weighting factor associated with those parameters that it searches for in the past. Remember, the black box, it looks in the past to look at the blue boxes based on the parameters. You can weight the parameters to find out what's more important. Say for ozone. Ozone is very related to, it's created in the presence of sunlight. So you may want to more heavily weight solar radiation. You may more heavily weight wind, because if the wind's blowing, it's going to blow the pollution elsewhere. So those are the type of things that we have to be cognizant of, and there's certain things that we can do to tweak those. Now, for the results of the ANN, there's different attributes that we use to assess the performance. The CRPS is an estimate of how close the observed values are to the predicted estimates. If CRPS is 0, it's perfect. It's a perfect predictive skill of the ANN. I doubt we'll find a 0 CRPS, but we can shoot to get it. Reliability, it's another metric. It's an estimate of the actual probability of the numbers versus the forecast probability. The best way to describe it is an example. So if the ANN forecast 5% of the days in 2018 to exceed the ozone NACs, you would think that the actual observed values exceed for 5%. If it is, perfect, you have great reliability. And then there's resolution, which is basically when the forecast shows an exceedance will or won't happen, somewhat related to kind of the hit rate that I was talking about. But here's a quick example from Dr. Delamonake's 2018 article. It shows an example ANN forecast, and I'll run through it very briefly. Is that the observed values are the black line here over a 48-hour period. The red line is simply a single deterministic model, CMAC. It's similar to the CAMX that I was talking about. And then, of course, the dashed line is the ANN mean, and the grayed out areas are essentially quartile ranges. So you can see, for one, ANN predicts much better than the deterministic forecast, but there are certain things that it can't quite do. You have a ozone peak in the day, you have a low in the night. Delamonake's work shows that the ozone forecasts are going to be close, but the things we want to find out are how close. What about those daily min and max for daytime and nighttime? And what about when there's a heat wave in the summer, when we have multiple days of this hot weather? To throw a couple of numbers out at you, in 2018, the State Meteorology Department, they forecast 12 code orange ozone forecasts. There was actually only 8 actual exceedances, and Penn State only got 5 of them right. So, we've got some things to work at, and that's kind of what I want to look into. To gauge the success of this project, I want to look at those types of metrics. So to gauge the success, I've posed the question of, will the ANN technique forecast day-ahead AQI values better than historical forecasts? I think it will. But even if not, I think the project will be a success, because it'll be the first to show that the technique is a valid forecasting alternative to typical forecasting, such as that by Penn State. They have their expertise, but maybe the state of Delaware will use this as a way to go forward, get rid of the human sort of component and go with this, this data-driven method. Well, to find out if I can answer this question correctly, I plan to present my work at the 2020 Hawaii Symposium hosted by the UCGIS in Honolulu, Hawaii at the end of next May. UCGIS is a nonprofit organization. It was founded by the U.S. National Science Foundation. The symposium is GIS and technologies, how they address societal needs. Since my project focuses on the technology of probabilistic forecasting and the societal needs of clean air, we thought it would be a great venue for a presentation. And proposals are due right around the corner on November 15th, so that's exactly what I'll be working on after this. So there's actually 7 months from now until the symposium, so I've got my work cut out for me, but we think that since, again, I already have most of the data necessary, well, there'll just be a short period for data prep, a couple months for running the initial runs, getting those factors and the weighting factors tweaked, like I said, a couple months to do the analysis, and a couple months to do the preparation of the paper and presentation. With that, that's my presentation. Here's a couple slides for references. And I'll thank you all for joining me this morning, and I'll give a special thanks to Dr. Savone and all the students at the GeoLab. They hosted me back in September. I came up to Penn State, had a wonderful time. Even got to meet Beth and Justine, and I really appreciate the hospitality I was met with there.
Any questions? Anybody either use your microphone to ask a question or type them in the chat?
All right, we have a question. Do you think you can use the CMAQ model as input? That's a good question. So the CMAQ model, again, it is a way to predict ozone in the future. It doesn't really predict, so my understanding of CMAQ, it's more used to predict ozone at a year. For example, EPA says that in 2023, Delaware's air quality is going to be just fine, that Delaware's air quality annually is going to be below the standard of 70 parts per billion. There are certain daily components that lead up to that. We would have to kind of pull that apart. So it's a possible value, but I'd have to look into that a little more. All right, another question. How might the research affect operations of the state of Delaware? Well, very good question. So, as I said, the state of Delaware had previously been contracting with Penn State University to do the forecasting. That contract ended actually this year in 2019. We're looking at procuring a new organization to perform the forecasting for the state of Delaware. It's honestly quite expensive to get a contract, and it takes a lot of time. As I said, a lot of things go into it. It has to happen every single day of the week, so there's got to be personnel and staff. I know the meteorology department in Penn State, they had both the advisors and students working on this every single day of the week. If my project can show that the ANN can predict ozone just as good, if not better, than the quote current status of how ozone is forecast, maybe the state of Delaware could actually use this method, save money, and create a better forecast that would be better for the citizens of Delaware and any other state potentially, to give them a idea of what tomorrow's weather and air quality is going to be. If we can say that tomorrow is going to be a code orange with much more certainty, those with asthma, those who are young or elderly, they're going to be much more appreciative.
Any other final questions? I think that might be it. Thank you very much, Mark,
All right, thank you as well.
for a great presentation, and I look forward to seeing your results. Our next presenter is Sarah. Sarah, can you load your presentation?
Hi, can you hear me?
Yes, I can.
Awesome. Do I just share my screen, or is there a place to load it into Zoom, or?
You can just share your screen or share just the PowerPoint presentation application.
I see. I don't want to give any spoilers away.
There we go. That looks good.
Does that look good?
Yeah. So whenever you're ready, go for it.
All right. I'll be presenting today on ideas of wilderness in modern land management. I currently am a forester with the U.S. Forest Service in Walden, Colorado, and I was approached by my supervisor maybe 6 months ago with the idea for this project. I'll get into the details here in a little bit, but I'm hoping that this is going to be really useful for my colleagues back on the forest. And that's sort of the inspiration behind it. So we'll be looking today at wilderness management, balancing ecological values of wilderness, recreational uses of the wilderness area, public safety, and things like that. First off, let's start what is wilderness. Wilderness is one of these ideals that is central, in my opinion, to the American spirit. Going back to Thoreau, Emerson, Muir, Roosevelt, Leopold, Abbey, so many philosophers, so many wilderness advocates, the basis of preservation and conservation, we know it, sort of rooted in this idea of wilderness. And one of my favorite quotes from Broome, the co-founder of the Wilderness Society, without wilderness, we will eventually lose the capacity to understand America. Our drive, our ruggedness, our unquenchable optimism and zeal, and Elon go back to the challenges of the untrammeled wilderness. And I love that word untrammeled here because if we look at the 1964 Wilderness Act, that word reappears in their definition of the wilderness. Here we have a photo of the wilderness area that I'll be focusing most of my research in. This is Roxy Ann Lake, one of my favorite hikes. Again, the 1964 Wilderness Act was the first to sort of define wilderness, and they didn't do a very good job. And so that's why we have the problems on our forest that we have today that I'll be working on fixing. The Wilderness Act was the first to put something in writing to protect areas as wilderness, recognizing that wilderness on its own was important for some intrinsic value aside from the ecological values that we get. Again, another nice photo to look at while I talk. Wilderness has, like Broome mentioned, wilderness is central to the idea of what it means to be an American in America, especially in the West, like here in Colorado. There's this feeling of the unknown, of being something small in the greater world that Thoreau picked up on back in Walden Pond, that is central to our identity. But aside from these feelings, these sort of untangible feelings of the pristine, there are also ecological values of preserving wilderness areas, of preserving watersheds and hydrology, of maintaining wildlife habitat and travel corridors, especially as urban areas encroach. It's important that we preserve large swaths of land as opposed to piecemeal bits here and there. Here again is the definition of wilderness. in contrast with those areas where man and his works dominate the landscape, is hereby recognized as an area where the earth and its community of life are untrammeled by man, where man himself is a visitor who does not remain, retaining its primeval character and influence without permanent improvements or human habitation, where generally appears to have been affected primarily by the forces of nature, with the imprint of man's work substantially unnoticeable, has outstanding opportunities for solitude or a primitive and unconfined type of recreation, is of sufficient size as to make practicable its preservation and use in an unimpaired condition, and it may also contain ecological, geological, or other features of scientific, educational, scenic, or historical value. And I find it interesting that in this defining act of what a wilderness area is, most of those values are those social values that I'd mentioned earlier. There's very little mention of hydrology and wildlife and botanical diversity, things like that. So I found that to be a little bit interesting, and it makes it difficult, therefore, to actually quantify and define what a wilderness area is and what it should be. And that's where we're struggling right now. I'll be doing my research in the Mount Zirkle Wilderness Area in Walden, Colorado. It is one of the original wilderness areas defined in the 1964 Act, and I'll give you some more details about the area itself here in a little bit. And I think I can say that we've done a pretty good job maintaining its wilderness quality. But there's one problem we're facing right now, and the gist of my project is going to be researching how this one problem could potentially affect the quality of the wilderness area as a whole. So like I mentioned, we have these multiple values, conflicting, possibly, maybe not, values of wilderness. And the task here is going to be to quantify these wilderness values, to say, yes, we're doing a great job, we're protecting this wilderness area, or no, we're not, we're actually letting human uses encroach and damage the reasons this area was protected in the first place. The U.S. Forest Service, the Rocky Mountain Research Station, has chaired an interagency team that published the first nationwide guidance for wilderness character monitoring. And I'll be using that protocol. As a U.S. Forest Service employee, I would like to be able to defend my research to the regional office and potentially the national office. So I'll be using the interagency guidance that has been published. It was worked on, a follow-up was published in 2015 with some improvements, so I'll be using that. And I'll get into that protocol a little bit later. But first, a little bit about the Mount Zirkle Wilderness Area. It was originally protected in 1949 as a primitive area, and that predates the 1964 Wilderness Act. And it had changed a little bit. I think the first push to protect the area was actually in 1931, and it achieved that protection in 1949. After the Wilderness Act was passed in 1964, it was renamed. The boundary was redefined slightly, although there were no major changes. It was mostly changes in wording. The area was subsequently expanded twice, and in the 1992 expansion, there was a push to change the boundary description. And they succeeded in changing part of it. Most of the original wording where the boundary itself had not changed remained the same. Where the boundary did change, this was the first description to actually include coordinates, geographic coordinates. And of particular importance to my project, they did change a section of the boundary to be buffered off the Grizzly Helena Trail, which is a motorized use trail in the area. And that's the section that I'll be focusing most of my work on. But the area in and of itself, these quotes are from the original 1949 protection. And they explain a little bit about what the area is like and why it was being protected. It's situated on the Continental Divide, high mountain lakes, pristine fishing waters. It was protected for its scenic value. And it was protected to include the headwaters of the Encampment River, which is an important river in the area. It fed a lot of logging camps, Native American camps, villages. In fact, I heard a rumor just a couple weeks ago that Encampment was originally supposed to be the capital of Wyoming, the town of Encampment built on the Encampment River. And I don't think it happened, but if you drive through Encampment, you'll see the roads are way wider than they should be. It was clearly built with grand visions for what the city was going to become, and it never really materialized. But the Encampment River then flows into the North Platte, which flows into the Platte and eventually into the Mississippi River. It's one of the major watersheds in this part of the country. And of note, this area was deemed suitable for protection as a wilderness because there were no operable stands of timber in the area. Most of the wilderness area is above tree line, and what isn't is so steep and rocky, it was deemed inoperable. So I find it interesting that in the original act to protect the area, they weren't so much trying to protect ecological resources as they were saying, well, you know, this land's kind of left over, we can't use it anyway, so we may as well protect it. But it's gorgeous. As maybe you've seen from some of the historic photos I've been showing you, those are from the 1949 document. Here's a photo that I took just maybe a month ago, just as the leaves were starting to turn of the area. Out in the distance, those are the Rewas and the Never Summers on the east side of North Park in northern Colorado, and I'm standing here on the boundary of the wilderness. The wilderness is behind me. This is looking out towards the east. And the document on the left, right, was quotes from May 24th, 1949. And I'm very lucky for this project to have access to all of the U.S. Forest Service files on the creation of the wilderness area and the subsequent additions. And this I find funny. So, like I said, the 1992 document was the first to include geographic coordinates. Prior to that, and the actual legal description in the 1964 Wilderness Act looks something like the document on the right, which I have a hard time interpreting. I'm not sure if I captured them on this page, but there are sections in it that refer to the quote unquote gates of Bear River, which all of the locals I've talked to, they have no idea what that is supposed to mean. I think there are some rocky outcroppings on a canyon that the Bear River flows through. But again, that's not very exact. Looking at this document, it doesn't seem like a very exact science. And I will note that even today, this is the legal description that we have to work with. And on the ground, most of the boundary is not marked. Most is pretty inaccessible. I think that was done on purpose. If you read this document, a lot of the boundary follows rocky ridges and clear changes in the topography, I think following cliffs. There's a mention of a rock slide here. I think that was done both to make the mapping and the definition easier and also to make the protection of the area easier. We feel that we don't need to go out and fence it or mark the boundary on the ground because people wouldn't be trying to enter from some of these places anyway. It's pretty inaccessible for most of the boundary. So we only have it marked at trailheads where people are likely to enter. And even then, it's marked at the trailhead and not at the boundary itself. Today, the Mount Zirkle Wilderness area is surrounded by Steamboat Springs to the west, Walden to the east, Encampment to the north. It's therefore pretty accessible. There are roads that connect Walden to Steamboat Springs on the southern edge of the wilderness area and a Forest Service road on the northern side that runs from Walden to encampment. Very drivable trailheads along the entire way. And these are popular for hiking and camping, accessing those virgin waters that they had mentioned for fishing, and for hunting. And hunting is probably the major industry, especially this time of year in Walden and encampment. It really keeps those two towns afloat. The watershed that the Mount Zirkle Wilderness Area protects is also extremely important. Steamboat Springs has a very popular ski hill, and they claim to have the most snow in Colorado. I don't know if that's true. Zirkles does get quite a bit of snowfall, and the snow melt is really what supports agriculture in Walden and in encampment and in the Yampa Valley where Steamboat Springs is. It's also, like I mentioned, great wildlife habitat and a travel corridor. Most of the area is above tree line, but what isn't, it could potentially be a travel corridor for larger predators that we haven't had in Colorado in quite some time. So lynx that are moving south from Wyoming are supposedly found in the area, as well as wolves, although people will argue you on that point. To the east of the wilderness area is the Grizzly Helena Trail, which I briefly mentioned before. The very popular motorized use trail. The northern 15 miles are open to ATVs. The rest is a single track. And it accesses many of those trailheads that head into the wilderness area for hiking and hunting. So this time of year in particular, you'll see people ATVing the trail, camping on the trail, and then hiking further into the wilderness to hunt, and sort of using that trail as their base camp. And in that previous picture I showed, the trail sort of follows the ecotone where we transition from the sagebrush of the valley below, through aspens, through spruce fir forests, and then up the tree line. So it's really gorgeous. Again, a photo from the trail taken just about a month ago. All right, so what is the problem? We have this gorgeous trail, we have this historic wilderness area. Well, the problem is that the trail is not currently mapped in the right place. This is a safety concern. Like I mentioned, a lot of hunters use this trail to access the wilderness area. And in some places, the trail is as much as a quarter of a mile off from where it should be. Someone could potentially hike a quarter mile the wrong direction, expecting to find a trail and wind up deeper in the wilderness area. And this is a safety concern. So we would really like to update our maps, but by moving the trail, it would cause the map trail to run through the wilderness area. And as we talked about before, the wilderness area shouldn't have any permanent improvements, should be untrammeled by man. Wilderness areas are closed to motorized use, and this trail is a motorized trail. So we're afraid that by updating the location of the trail, it appears that the trail will encroach on the wilderness area. And on the ground, like I said, it's not mapped. The wilderness area in reality has always ended at that trail, but the maps won't show it like that. So what do we do? What's important? How important are these maps in the public perception of what we're doing to manage the wilderness area? So there's a bunch of questions I'm going to attempt to answer. Has the trail actually moved due to reroutes or user-created trails, or is it just better mapping? I showed you that the original description was pretty vague. It's possible that it's just been mapped in the wrong place over time. If the trail has actually moved, are we losing wilderness? There are places where it encroaches on the wilderness, and there are places where it's actually pretty far off the wilderness boundary. So we might be gaining land in some places, whereas we lose it in others. Why did the trail move? Is it indicative of a loss of wilderness quality? Like I said, part of this project, I'm going to be looking at quantifying the wilderness quality. Is the trail moving because soils are eroding, because hydrologic conditions are changing? That might be just a symptom of a bigger problem. There might be other factors affecting the wilderness quality, and this trail is just our canary. So like I was just talking about, how does this affect the wilderness quality? What effect on the wilderness quality does the presence of the trail so close to it really have anyway? In my mind, having a motorized use trail right on the boundary of the wilderness, I have to admit that the quality of the wilderness 10 feet off the trail is probably different than the quality of the wilderness a mile away. So why should the trail even be there? Should it even be a motorized use trail? Does the trail affect the wilderness quality itself? What if the trail is in a different location? If it does encroach on the wilderness area, does this really affect the wilderness quality of the area as a whole, or just in that one location? Do these protocols that attempt to quantify wilderness quality, do they factor in things such as safety concerns and public use? Public use is really important for defining a wilderness area. This particular wilderness area, that original document I showed you, seemed to mention nothing but social factors. They talked about the scenic views and the fishing opportunities there. So if people can't safely go and hike and camp and enjoy those views and enjoy the fishing, that should affect the quality of the wilderness itself. And then finally, since I'm doing all this work looking at the area, I would like to complete one of these surveys and actually find out, what is the wilderness quality? Are we doing a good job? Has it changed over time? Will it change? Would changes to the boundary drastically affect it? Or should we just change the boundary to match the trail? Everyone's safe, everyone's happy. Like I mentioned, I have the original documents, and this project will be sort of completed in 3 parts. I will use those original documents for a historical GIS analysis. There will also be a social survey component, and then a little bit of GIS work with the new GPS survey that we did of the trail. I'll get into now. Like I mentioned, there's lots of different ways to quantify wilderness, and I'll be doing the Peter Lander's Keeping It Wild, an interagency strategy to monitor trends in wilderness character across the National Wilderness Preservation System. That's the protocol I'll be following. There's quite a bit of literature out there, different protocols. So I need to go in and look a little bit more closely at those. I had hoped to have that completed by now, but I ended up losing 2 weeks to GPSing the trail itself. I wasn't expecting to be able to get out on the trail so early, so that sort of shifted my thinking and my preparation for this presentation a little bit. But I was able to get out on the trail. So I think this project, this is phase 1 of the project. I GPS the trail. I still need to go in and make some minor corrections to it. But once I have a trail that I'm satisfied with, I'll be comparing that to the current location and the current wilderness boundary, just to see how much ground was really gained and lost. That's the simplest question. This project might become irrelevant very quickly if we find out that there's not much change. But I can tell you, I wish I had a better photo for you here, but while I was GPSing the trail, we had what is currently published as the trail location loaded onto our Trimble devices, and we were very off for most of the trail. So there will definitely be some difference. The question is, I know we've gained land in some places and lost it in others, so what is the net difference? Phase 2, like I mentioned, is a historical GIS analysis. We have 4 different wilderness boundaries historically. We had the 1931, 49, 64. Oh, I guess there's 5, 78 and 92. And then again, the trail has obviously moved over time. So I need to still hunt down historic locations of the trail that I do not have. But if I can find that, then I will compare the trail today versus in the past. Sorry, I got that chat. So I'll be doing a historical GIS analysis looking at how the trail has moved over time. Why maybe the trail has moved. Again, are these just mapping changes or has the trail itself actually moved? And then if you remember that original description I gave you being as hard to read and vague as it is, I think I'm going to ask volunteers with varying levels of experience just to attempt to digitize a section of that boundary, the section along the trail, just to see what we come up with. I think it would be fun. I think it will get people in my office interested in this project. And it will go a long way to show that maybe that legal description really isn't what we should be tying all of our future changes to. Maybe we shouldn't be so worried as we are about messing with the historic boundary. Maybe the safety concerns of an incorrect trail are really a priority. So then phase 3 is the social aspects. We'll create mock-ups of the various maps, products that we might publish. Again, our options here are to correct the trail, which will make it look like it's encroaching on the wilderness, or to move both the trail and the wilderness, or to leave it as is, or potentially straight through. Do we really need the trail on the map of the wilderness and the wilderness on the map of the trail? I'm not sure. So I'll be creating a survey. We'll be asking the public to identify features, to interpret the maps and make decisions, and then just for general preferences and what they like and how it looks, to get a baseline on what their experiences reading maps really are. And finally, phase 4 would be to calculate the wilderness qualities, to use one of those protocols I'd mentioned, and to look at what it was originally in 1964, what it is now, versus how changing the trail and changing the wilderness boundary might affect that. And I'm most interested in which of the factors are going to change, whether it's the trail or whether it's false advertising or whatever you want to call it. So like I said, I'm expecting to conduct a survey and to make those 4 mock-ups of the maps that I will present to my supervisors here so we can make a decision about how best to approach this problem. Do we move the trail right now, or do we wait until we can possibly modify the wilderness boundary designation itself to make things neater? I would like to be able to come up with one single proposal for my supervisors based on all of this data that I've collected. And yeah, any questions? I think there are some things I glossed over, so. Yeah, I have a question. Wilderness quality is an interesting concept. Is there an opportunity to critique the protocols in addition to using them? Yeah, I think there is. I might be able to, like I said, I wanted to look a little bit more at some of those other protocols. I'm very familiar with the U.S. Forest Service protocol, not so much the other ones. So it would be interesting to me to maybe run the same analysis using one of those other protocols to see what the differences are. And I'm expecting that the idea of safety concerns and public ease of use and ease of access and recreation issues like that, I'm sort of expecting that those aren't going to be featured in any one of those protocols. So I might need to find some way to add those in myself. Another question, what might have shifted the boundaries of the trail over time? What might those be? Yeah, so I briefly mentioned that it could simply just be mapping errors or better mapping now, or even not necessarily errors, but more accuracy. When I flipped through these, the 1949 map of the area is the scale is so large, they effectively just drew the boundary on there with a Sharpie. So it's really hard to tell where the boundary was actually supposed to be. So that's my guess, is that we just have better mapping now. But if the trail itself has actually shifted, most likely that would be due to sort of user-created reroutes, which would take a very long time to shift as much as it has. You know, where it gets super muddy in one area, so an ATV rider rides a little bit upslope. That's probably what you see most often. There may have been some official reroutes over time that sort of got lost in the shuffle. Nobody recorded that they had done a reroute, but I might find some of those as well. Okay, will you be using any Esri apps for the project? New tracker and quick capture seem appropriate for data capture in the field. I'm not, besides ArcMap, or actually I'll be probably on Arc Pro by then. But in terms of apps in the field, no. All of the data collection was done on the Trimble devices. We were really looking, that's just what we have in the office that we use when we need something really accurate. That's what I had access to. And we were using those Trimbles for the sub-meter accuracy. And for most of the trail, we were able to get sub-meter. There were sections that were hovering at around a meter. I haven't looked at any crowdsourced GPS trail info. But I might, like I mentioned, I'm lacking historic info for the trail. So if I can't find any, I might go that route and just pull a whole bunch of crowdsourced GPS info to compare between.
That's it for questions. Thank you. That sounds like a fascinating project. It'd be interesting to see how your boundaries differ and the differences that you identify.
Thanks.
Oh, you have one more. Nope. Topo view, there's just a comment that was added by Karen.
Oh, awesome. Thank you. Okay.
Okay, if you could stop sharing, great, thank you. Our next presenter. Great. I think you're, yeah, if you can load that, and then whenever you're ready. You need to unmute your microphone when you're ready. Okay.
Is that better?
Yes, I can hear you now.
Good afternoon, everybody. My name is Jean Nebre. I am here to present my capstone project on the positional accuracy assessment of a DJI Phantom 4 Pro on a non-vegetated surface. As a quick overview, commercial operations for drones have become commonplace, especially in engineering and surveying, in conjunction to the certificate of waiver or authorization process. It is no longer needed since, of FAA Part 107 being released 3 years ago. In our company, we have acquired a few drones, starting with the Phantom 4 Pro. We are now being tasked to find other applications for the drones, which includes using them for topographic surveys, especially in unreachable areas. But I'm a professional land surveyor in the company. And as a professional land surveyor, we are regulated by law to produce products that meet minimum standards of accuracy. And so now it is my goal in this project to determine if the Phantom 4 Pro acquired data and products meet the minimum standards of practice in Maryland and the ASPRS positional accuracy standards for digital geospatial data. I have 4 basic objectives for the project. One is to test the positional accuracy, both horizontal and vertical, of the products created by the Phantom 4 Pro. Second is to test with 4 ground control points and a minimum of 20 independent checkpoints per the ASPRS standards. And the third one would be to establish the ground control points using traditional control and a level survey network, as opposed to just doing individual GPS points. And finally, to identify the appropriate uses of the UAS flown data, especially the elevation data. Our certified drone pilot will be flying a Phantom 4 Pro, as I said. It can reach a maximum speed of 45 miles per hour, a maximum ceiling of 6,000 meters above sea level, a maximum wind speed of speed resistance of 10 meters per second, and a maximum flight time of 30 minutes. The operating temperature range for the Phantom 4 Pro is 32 degrees to 104 Fahrenheit. I think it's very important to note that because winter is approaching, and I need to have it flown before winter. And then our survey field crew will be using a Leica GS07 to establish the ground control points with the rapid static mode, which will give us an 5 millimeters plus 0.5 parts per meter horizontally and 10 millimeters plus 5.5 parts per meter, parts per million vertical accuracy. It has an operating temperature of negative 40 degrees to 149 degrees Fahrenheit. On top of using GPS to establish the ground control points, the field crew will also be running a level loop to get better relative vertical accuracy. Depends. Our field crew has 2 kinds of total stations that they use in the field. And these will be used to shoot the 20 independent checkpoints in the project area. It depends on which one of the crews will be out there on that day. That it will either be a Trimble S5 like this. This is a robotic total station, which uses an electronic distance meter that constantly tracks the prism as it is moved by the rodman, or a Trimble C3, which is a mechanical total station that also uses EDM, but it doesn't automatically track the prism. And it does both things. It does measure angles and distances, and using a light source, a laser. Either one will provide the same results since they have comparable positional performance. And the only difference would be just that the robotic total station would cut on the field time. So broadly speaking, my methodology for the project would be to use our existing processes and then include analysis in between them. So at first, the project will be flown by our certified drone pilot. he will as usual, he would develop a flight plan for the project area that I specify, but I will also develop a flight plan myself. And then we will add, once the guys in the field establishes the controls, he will go out and fly both flight plans on the same day. And then the photos will be given to me, and I will do the processing for the using our in-house drone to map software. And I will also use a Pix4D software that I have to compare if there's any change on that one. And then the data sets will be evaluated against the independent checkpoints, and then it will be compared, you know, the two flight plans will be compared. And finally, a report and presentations to the stakeholders at work will be done. From my literature review, I have identified 5 papers that have similar objectives and methodology. And here they are in chronological order. I'll discuss each one of them. This paper in 2012 used between 5 to 27 ground control points and compared it to a traditional survey instrument, a total station, and a Leica GPS unit. So it's very similar to what I'm trying to do. The results showed better accuracy on the total station as opposed to the GPS unit, but they did not use independent checkpoints, which is not how ASPRS recommended to do with the testing. This 2015 study did use quite a lot of ground control points and checkpoints, and it compared the EB results with GPS. They did use the ASPRS standards for surveys, and the ASPRS standards indicate that vertical checkpoints be surveyed on flat, uniformly sloped terrain with slopes of 10% or less. It is not clear, however, if the terrain used for this project meets that slope criteria. Excuse me. Because it used GNSS as control, the accuracy class was limited to a 10 centimeter RMSE for both vertical and horizontal. This one used a DJI Inspire quadcopter and an EB and compared it to a Trimble GPS. Excuse me. Halsey used ground control points and checkpoints as well, but the checkpoints were not as much, and the minimum standard is 20 checkpoints. And then this project is on a non-vegetated urban setting in Brazil. And although the project uses ground control points and the appropriate amount of checkpoints, it does not analyze the results using the ASPRS standards because the project was in Brazil. So they were evaluating it for the urban setting under Brazil's regulations. It also used GNSS receivers for setting control, and it's over an extensive area. Now, lastly, this project was set up in a quarry that is also vegetated. They compared results for the 0 ground control points and then with 4 ground control points, and they concluded that it is better with at least 4 ground control points. They used GNSS receivers on rapid static mode with 3-minute observations, which is similar to what I'm doing. Because the results varied so much between the studies from all 5 of them, I have found that the methodologies involved also varied a little bit. And I think this is an opportunity to test out the DJI Phantom 4 Pro in our current settings and work environment. So this is the project area I've identified. It's an abandoned parking lot. We'll be using 4 ground control points and a minimum of 20 independent checkpoints as recommended by the ASPRS standards. The possible issues we may encounter is getting buy-in from the top managers in the company. Is also a garden parking lot, although it was abandoned. But I have talked to the guard and he doesn't really care as long as we're not destroying anything in the parking lot. There may be some car traffic along the drive aisles because at the back of it, there's an existing shopping center, and some people still use the drive aisles, but not the parking lot. There will also be overhead costs involved in having the field crew and the pilot fly the drone. And that's one of the factors involved in this project. Because this site is in Maryland and we're working, I'm doing it under our current company's procedures. I have to do it under the Maryland State Highway field procedures, and some of the constraints that have to be used is that the setups between turning points and benchmarks for elevations has to be 250 feet or less, and the traverse points has to be 266 feet minimum. I'm also constrained on the time because the capstone presentation has to be done in spring for me. And so ideally I have to do the field work before winter. The projects that used, so why is my study significant? It's because the projects that use the DJI-4 Pro with checkpoints did not use the ASPRS positional accuracy standards that I know of. And so they're testing it primarily because it was tested outside, like Brazil and Netherlands. It's also unique because it will compare to an adjusted control network, adjusted level network, as opposed to just using individual GPS reference points. It will hopefully definitively answer the use of the drone for us, especially on non-vegetated surface, based on our current procedures at work with planning, flying, and processing of the drone data, I mean. I'm looking to submit my abstract by the end of this month to hopefully get to present at Geo Week 2020 in March here in Washington, DC. And that's it. Any questions? So I will be using Pix4D and Drone2Map. Drone2Map is the one that the MGIS guys use to process here in the office, but I do have the Pix4D software at home. I know the Drone2Map is, I think, built on the Pix4D platform or something. That's what the guys told me, the ones who use it. Yeah, yeah, that's what they told me, but I haven't really looked at it. I haven't really had the opportunity to work with it. Is it is it similar, or is there like features that it don't exist in the drone to map compared to the Pix 40? That's what I was wondering. Actually, I was just at the conference for the Maryland Society of Surveyors last weekend, and there's still a couple of companies who had the EV on there. They're still marketing it. Oh. I think Karen's was private. She said drone to map is in Pix 40. Is actually Pix 4D with the Esri graphic user interface.
Are there any other questions? I have a couple of questions.
Okay.
Have you already done some preliminary, I might have missed this, preliminary flights to look at what some of those accuracies or what you're going to expect with the accuracies?
Yeah, so the guys that are flying Phantom 4 Pro, I've looked at forums, and it seems like it varies a lot depending on the terrain, and so I think that's why it might be a good idea to that's why I picked a very flat, like even area, like there's not a lot of vegetation, because I think it varies a lot depending on the accuracy they get depends on like what's on there, like if there's vegetation and it's just bare ground. And that's why, like with the ones that I've identified are similar in mine, it varies with accuracies. It can go to like a couple of 10 centimeters and to very good ones that are 2 centimeters. But with the vertical, that's the big question. It's kind of like, for the surveying community, it's kind of like a blanket statement that drones are as good as half a foot, which for engineering purposes for us, like who design pipes that flow, half a foot makes a lot of difference between, it flowing north and flowing south. So it's still something that I think we really have to test.
I think that's it for questions. I don't see any more. Thank you very much, and look forward to seeing your results.
Thank you.
So we have one final presenter, Jessica. Thanks everybody for hanging in there.
Right.
Always
Hello.
the last one. So whenever you're ready, Jessica, go for it.
Great. Can everyone hear me?
Yes.
Great. So hello, thank you for joining for the last presentation. My project is titled Characterizing Historical Patterns of Ownership in McKean County, Pennsylvania. My name is Jessica Smucker, and my advisor is Dr. Erica Smithwick. So one of the focuses of my study is on parcelization. So I thought it would be good to start out with some definitions. A parcel represents the extent to which an individual or agency owns real estate. And parcelization can be defined as an increase in subdivision of parcels over time. So as you can see, there's a whole parcel in year 1, and then in year 2, there are 2 or more parcels. So parcel shape has been strongly linked to land use contours. For example, in this image, the golf course is using the full extent of the parcel boundary. So I look at parcels all day as my job as a GIS analyst at the Western Pennsylvania Conservancy, or WPC. WPC is a nonprofit that protects and restores exceptional places throughout Western Pennsylvania. One of the main focuses of WPC is protecting our valuable and unique forests that provide habitat to many species and provide recreational opportunities for people, such as hiking and hunting. Each property that WPC acquires has its own unique land use history, and understanding this history can help us to manage the property properly and anticipate future trends. So recently, there has been a concern about the state of forest land ownership. Studies have found that forest land has become increasingly parcelized over the past century in many parts of the United States. And in addition, in the past 30 years, there has been a transition from industrial forest land owners to investment management organizations. And there are still a lot of unknowns about how these companies manage their land and if there is parcelization occurring. This is a concern because ownership type and parcelization have both been linked to changes in landscape condition. And finally, there's limited information about how parcelization and ownership trends specific to the Allegheny Plateau region of Pennsylvania, which is a valuable forest land area. So considering that, here are my research questions. The first is, what are the ownership trends specific to McKean County, Pennsylvania? Is parcelization increasing at the level of the study site? And are there identifiable ownership trends linked to specific parcelization types? So this is McKean County, Pennsylvania. It's in the northwest region of Pennsylvania. So who owns land in McKean County currently? So the western side of the county is covered by the Allegheny National Forest, that's shown in green. And on the eastern side of the county is state ownership, which is shown in orange. And the rest is a combination of different owners, including industrial, non-industrial, nonprofits, municipalities, and the investment management organizations. So McKean's forests have been used as a supply to meet economic demand throughout the past century. McKean County is part of the Allegheny Plateau ecoregion, which consists of a hemlock hardwood forest. Forests cover about 58% of Pennsylvania, but they used to cover about 90% before colonialization. And the region has undergone changes in forest composition as a result of or in transition with forest ownership trends. Prior to colonialization, the Native American Iroquois lived in Pennsylvania. And then in 1784, there was the Treaty of Fort Stanwix, which was also known as the Last Purchase. And the Iroquois were forced to leave the region. McKean was then officially recognized as a county in 1804. And then a few wealthy individuals started buying up the land, including the Holland Land Company. White pine was then harvested to meet demand of industry in Pittsburgh, and the trees were actually shipped along rivers downstream. Then in the mid-1800s, wood and chemical companies started cutting down the eastern hemlocks to create calcium acetate to meet the demand of the tannery companies. And that's what's showing in the image on the screen. The pulp and paper industry also bought land in McKean, and one of the largest owners was the Hammermill Paper Company, who used hardwood trees. This company was then transferred to the International Paper Company in 1986. Finally, in recent years, there's a shift towards the timberland investment management organizations. Conservationists started to respond to this overharvesting starting at the beginning of the 1900s. People termed the land the Allegheny Brush Patch because of how overharvested it was. And the Allegheny National Forest, as a result, was established in 1923, and conservation efforts continue to this day. So to reflect and capture this history, I'm using historic ownership maps. The McKean County Assessment Office provided me with ownership boundary maps as far back as 1876, and at that time they were hand-drawn. And as you can see through time, surveyors use many different methods for recording ownership, and the information captured varies from year to year. So here's a list of data that I have acquired, starting with the 1876 maps, moving to the 1930 and 34 maps. And then in 42, well locations were noted. In 1956, they updated the map again, and this map was updated in 78 and 97. And then I have data from 2007, and then the current tax parcel data. So here are my methods. First, I will georeference the maps working backwards in time. I will draw vector boundaries based on the maps. I will add tracking numbers and ownership names to the parcels, summarize the number of properties and acres by the ownership names, and then categorize the type of ownerships for each year based on the top owners, link the parent and child parcels with the tracking numbers, do a two-step cluster analysis to categorize the parcelization types, compare parcelization types to specific ownership transfers, and determine the adjusted mean score for each year. So the first and most tricky part will be georeferencing these old maps. Maps will be georeferenced working backwards in time, starting with the current parcels, assuming that the current parcels have the most accurate standards and representation of the parcels. The PA map aerial imagery will be used along with street vector data, and the parcel boundaries themselves will be used as reference for control points. So to assess parcelization trends at the landscape level, I will generate an adjusted mean score for each year and compare this score between years. So Kilgore et al. Compared many different metrics that assess parcelization and concluded that the adjusted mean score was one of the best metrics to use. So the adjusted mean score simplifies to the percent of private forest land in parcels below a parcel size threshold multiplied by the number of private forest land parcels. They used 40 acres, which is basically the smallest size at which a forest can be managed. And as you can see on the example on the left, the adjusted mean score is 1.75. This is not as parcelized landscape. And the example on the right is more parcelized, and the adjusted mean score goes up by 5. And the difference between the adjusted mean score is very different between these two examples when compared to the mean size. So adjusted mean captures parcelization better than just average size of parcels. So to capture parcelization at the parcel level, I will use methods from Donnelly and Evans, 2007. What they did is they clustered parcel types. They created parcel types based on the number of child parcels and then they clustered again based on the range ratio. So the number of child parcels is basically the number of subdivisions. So as you can see in the second example down, that would be 2. And the range ratio is basically how different are the areas of the subdivision. So the range ratio in the second example down is low, and the range ratio in the third example down is high. Another type that they added in that's not accounted for here is when parcels are combined. So they added that in as a third type, and they found that this type was not represented very much, but it was important to include. So once these parcelization types are generated, I will summarize ownership transfers by these parcelization types and assess if there are ownership transfers characteristic of these parcelization types. And in order to compare ownership transfers and their associated parcelization types, I will first have to characterize types of owners. So to do this, I will summarize ownership names with the summary statistics tool in ArcPro. And then ownership types will then be generated based on my research of the top owners. And then, although seemingly simple, ownership type can be difficult to define. Is public land actually public? Some public land might be used for logging in some cases. But to narrow it down, I will use some categories studied in Summing and Sater with some of my added categories. And these categories are non-industrial private forest landowners, industrial forest landowners, the timberland investment management organizations, non-government organizations, federal, state, municipalities, and others. So here are my anticipated results. I anticipate that there'll be an increase in number and types of owners through time, an increase in parcelization through time, certain parcelization types characteristic of certain ownership transfers, and transfer of land from industrial forest land owners to the timber investment management organizations between the 78 map and the 97 map. So I hope this study provides conservation professionals with a more in-depth and analytical view of ownership history in McKean County. The results might show particular areas that have increasing parcelization through time, and these might be priority areas for conservation. And it will be interesting to see if all industrial timberland was in fact transferred to the investment management organizations, and if any subdivision occurred during those transfers. Or if they, it's also possible that the investment management organizations purchased a bunch of smaller parcels and combined them. Either way, knowing the facts will allow conservation professionals to respond in an intelligent manner. And I also just think having these data layers will be valuable when we look at a particular property so we can trace its lineage through time. So here's my timeline. I'm presenting today, and then I will revise my written project proposal and submit based on your feedback and my advisor's feedback by October 31st. And then I will conduct the analysis based on the proposed methodology by the end of January. Apply for conferences also by the end of January. And then by the end of June, finalize the project, submit my final paper, and present at a conference. And here are a couple of possible venues: the American Association of Geographers Conference and the International Association for Landscape Ecology Conference. And here are my references and any questions. Oh, thank you. Okay, I got a question. Although you're only concentrating on one county, do you think this can be extended to other counties in PA? Yeah, so I actually gave this presentation to my colleagues on Wednesday, and they were really interested in the topic. And after I get the results from this county, I hope to go to other counties and show them the results to see if I could get data from them to see about particular history in their county as well. So another question, does McKean County already have GIS layers for you to use? Yes, so all of the historic maps are up to 1997 are in JPEG format, so those will all be geo-referenced. And then the other two layers that I have are from 2007 and 2019, and both of those are already in the GIS system. Yeah, that'd be really interesting. Maybe do like a time lapse of the ownership trends through time. That might be a really interesting and neat addition to my project. Thanks for that suggestion.
Any other questions? I think that might be it. Thank you very much. It sounds like you have a neat project ahead.
Thank you.
We look forward to seeing the final results.
Thank you very much.
Thank you everybody for joining us. Great presentations by everyone, and this was the last of the peer reviews. Don't forget to provide feedback, and have a good afternoon.